Hello, today's April 29th, 2014. I'm Will Nichols from the Neon Tape Corporation, and today I'm going to be demonstrating and teaching you about the three laws of Newton. The first law of Isaac Newton states an object at rest will stay at rest, while an object in motion will stay in motion, unless acted upon by an unbalanced force. What this means, if I have this ball stand still, it will remain still. If nothing touches it, it won't move. But if this ball moves, then it will keep moving until a force acts upon it, like gravity or friction, or it falls off something. But if nothing touches it, it will keep moving. Well, Isaac Newton says it will basically keep moving it forever. Now, obviously, this is not going to move forever because there's gravity and there's friction and there's everything pushing on it. But basically, if I move it, it's going to stay moving, and if I keep it still, it's going to stay still, which is the first law of Newton. Another example of Newton's first law would be this yo-yo. Because of the knots that are tied within it and the potential energy that is acting upon it, this yo-yo will move as I give force to it. If I don't give any force to it, it's not going to move. Therefore, Newton's first law is an object at rest will stay at rest, while an object at motion will stay in motion. The second law of Newton states that the force of an object is equal to its mass times its acceleration. Sounds difficult? I will demonstrate it to you. It basically means that the heavier something is, the more force it takes to push it. For example, if I have this 3-pound weight here, I can bring it around town and I can walk with it because it's easy, it's light, and I won't have a problem with it. Same thing with this ball, I won't have a problem moving around with it. An 8-pound weight may require more force. But what's even more heavier, if I take, for example, this chair, I'm going to have to lift it with 2 hands because it's heavier, so I'm going to have to take more force to push it. So basically, the heavier something is, the harder it is to move, which is Newton's second law. Another example of the second law would be if I take this ball, throw it into the air, and drop it, it doesn't take that much force. It's light. I could easily throw it and not very easily catch it. But if I take this ball, as opposed if I went to the bottom of this chair and tried to lift it up, I mean, I might eventually get it, but it's going to be a little hard. You can't really throw a chair in the sky easily unless you're like Superman. So, therefore, the second law of Newton is the force of an object is equal to its mass times acceleration. The third law of Newton is for every action there's an equal and opposite reaction. For example, if she pushes on her, she's acting, which means she is going to react on the other side. So therefore, you have Newton's third law.
Okay, we're done.
So basically, if you push against something, something will push against you with an equal or opposite force. Lastly, another example of Newton's third law, say I take this tennis ball and I'm going to drop it on the ground. Now trust me, you're going to have to trust me on this, there is ground here, I am not standing on needles, okay? So I'm going to take this tennis ball and bounce it really hard. And why that is Newton's third law is the tennis ball is bouncing on the ground. It's acting on a force. The ground is reacting by pushing it back up, which is basically Earth's gravitational pull. So you push push at that, and it's not pushing on the needles, it's bouncing on the ground. So, that is Newton's third law, everybody. Which is... DVD. For every action, there's an equal or opposite reaction. For all you science people out there, I'm Will Nichols, the Neon Team Corporation.